G'day nerds. So today we're going to look at induced dipoles. Now, by the end of this, we should be able to understand what an induced dipole is, how it creates, how it's created, and the attractive forces that it can bring. By the end of this, we should be able to model it using either, say, plasticine or molecular models. Now, what is an induced dipole? First off, let's have a look here at oxygen. So oxygen is a non-polar diatomic molecule. Now, an induced dipole moment, because we're talking about movement here, okay, so an induced dipole moment is when the charge of a dipole in species X, that's the one over here, see, we've got water, which is a permanent dipole, either attracts or repels the electrons from another species, in this case, Y. So we've got our non-polar oxygen, and we've got our permanent dipole, and as they come together, this area here is very negative. So what it does is it forces, or it repels, all of the electrons to the other side of the molecule. And when it does this, we have this weak induced dipole right here, and they're attracted to each other because this end is a little bit more positive, this end's a little bit more negative. And this is a momentary dipole in species Y that is induced. The momentary means it is transitory. It will pass. Once this molecule gets a bit too far away from the water, it'll revert back to non-polar. And so this can also lead to partial solubility. So oxygen is actually not that soluble, but it is what we call partially soluble. There's a small amount of oxygen dissolved in water. And this is really important because that small amount of oxygen dissolved in water, that's what gives us life. Like without that, there's no life in the ocean. Fish, for example, filter that oxygen out of the water. So, what is an induced dipole attraction? It's the temporary dipole causes an attraction. So here we have a permanent dipole, and it will attract, so it causes a temporary dipole in the xenon here, and the xenon is then attracted, because the electrons are pushed over this side here, and the xenon is attracted to the chlorine here. It's a weaker attraction than a permanent dipole attraction, and it doesn't even have a touch on a intramolecular bond. Really, these intermolecular bonds, and they are much, much weaker than intramolecular bonds. And it's also much, much weaker, also a bit weaker again than a permanent dipole. Hope that made sense. If you have any questions, pop in the comments below, and we'll get back to you as soon as we can. Thanks for watching. See you next time. Bye now.